Hi everyone. Today we're going to be solving AQA GCSE Chemistry, Higher Tier Paper 1, June 2020. This is a part 2 of the video, and inshallah in this video we're going to be solving from question number 4 to question number 9. This question is about electrolysis. A student investigated the electrolysis of copper chromate solution. Copper chromate solution is green. Copper chromate contains blue colored copper 2 plus ion and yellow colored CrO4 2 minus ion. Figure 1 shows the apparatus that is used. We can see DC power supply. We can see positive and negative terminals. We can see a YouTube green copper chromate solution. The student switched the power supply on. The student observed the changes at each electrode. Change at positive electrode. The solution turns yellow. So, in the positive electrode, we are going to see that the chromate ions are going there, CrO4 2 minus. And at the negative electrode, the solution turned blue. That means copper 2 plus ions are migrating in that electrode. Alright, bubbles formed at the electrode, in the positive electrode, and solid formed at the negative electrode. Explain why the color changed at the positive electrode. We will say the chromate ions have moved to the positive electrode. Alright, because chromate ions are negatively charged and the positive electrode is opposite charge, and opposite charges attract each other. The gas produced at the positive electrode was oxygen. The oxygen was produced from hydroxide ions. Name the substance in the solution that provides the hydroxide ions. So, we know that water is in solution, and water is H2O, and H2O splits into H plus ion and OH minus ion. Describe how the solid forms at the negative electrode. At the negative electrode, the copper ions are migrating. At the negative electrode, the copper ions are migrating. The copper ions will gain 2 electrons from the negative electrode and will turn into copper metal and get deposited. Guys, this is the ionic equation. However, this is not required. Just for your understanding, I have given you this one. The student repeated the investigation using potassium iodide solution instead of copper chromate. Name the product at each electrode when potassium iodide solution is electrolyzed. Guys, we have to understand potassium iodide contains potassium ion and iodide ion, and because it is a solution, that's why it contains H plus ion and OH minus ion. So when we have the positive ions competition between the potassium and hydrogen, hydrogen is lower in the reactivity series. So definitely negative electrode is going to produce hydrogen. Guys, between iodide and hydroxide in competition, iodide is going to win the competition. So, in positive electrode, iodine is going to be produced. This question is about the development of scientific theories. Figure 2 shows a timeline of some important steps in the development of model of atom. So, what we can see, between 1890s to 1900, electrons were discovered, plum pudding model was discovered, and between 1910 to 1920s, we got alpha particle scattering experiment and nuclear model. We got Bohr model. We got protons, which were then discovered. Between 1930s to 1940, neutrons were discovered. The plum pudding model did not have a nucleus. Describe 3 differences between the nuclear model of atom and the plum pudding model of atom. In the nuclear model, atoms are mostly empty spaces. But in a plum pudding model, atoms have no empty spaces. In the nuclear model, the positive charge is all in the nucleus. But in the plum pudding model, atoms is a ball of positive charge with electrons that are embedded, in certain portions. The mass is concentrated in the nucleus in a nuclear model, and in the plum pudding model, the mass is spread out. The electrons and the nucleus are separate in a nuclear model, and in a plum pudding model, the electrons are embedded. Niels Bohr adapted the nuclear model. Describe the change that Bohr made to the nuclear model. So basically, Niels Bohr, he made changes such that electrons orbit the nucleus and electrons are at a specific distance from the nucleus called the shells. So these are the energy levels where electrons are most likely to be found out. Electrons are not like they're scattered throughout the structure of the atom. Mendeleev published his periodic table in 1869. Mendeleev arranged the elements in order of atomic weight. Mendeleev then reversed the order of some pairs of elements. A student suggested Mendeleev's reason for reversing the order was to arrange the elements in order of atomic number. Explain why the student's suggestion cannot be correct. So, atomic number is the number of protons, and protons were not discovered until later years. So, Mendeleev's proposal, this particular proposal would be definitely wrong. Give the correct reason why Mendeleev reversed the order of some pairs of elements. Mendeleev reversed the order of some pairs of elements so that the properties that they have that can match the rest of the group. Because according to Mendeleev, elements belonging to the same group has similar chemical properties. This question is about displacement reaction. The displacement reaction between aluminium and iron oxide has a high activation energy. What is meant by activation energy? The minimum amount of energy that is needed for particles to react or for a reaction to occur. A mixture contains 1 kilogram of aluminium and 3 kilogram of iron oxide. The equation for the reaction is 2 aluminium plus iron oxide producing iron plus aluminium oxide. Show that aluminium is the limiting reactant. So to do this particular process, what we're going to do is we are going to find out the MR of Fe2O3. So since we have 2 irons, so we're going to multiply 2 with 56 and we have 3 oxygens, so 3 with 16. So our total comes out 160. Then we are going to find out the moles of Fe2O3. So when finding moles of Fe2O3, we are going to divide Fe2O3 3 kilogram, that means 3000 grams. 3000 grams, we are going to divide it by 160. Our answer comes 18.75 mole. Then we will do stoichiometry. For 1 mole of Fe2O3, we need 2 moles of aluminium. So we will find out number of moles of aluminium. So in this case, we are getting 1 kilogram, which is 1000 grams. So 1000 gram divided by 27. Our mole comes out 37.0. Aluminium is the limiting reagent because, so we are going to say aluminium is the limiting reagent because 37.0 mole is less than 2 times 18.75 according to the reaction stoichiometry. 2 times 18.75 or which is equals to 37.5 moles needed. However, it is less than that. That's why aluminium is the limiting reagent. Magnesium displaces zinc from zinc sulfate solution. Complete the ionic equation for the reaction. So when we have magnesium solid, it's reacting with Zn2 plus aqueous. Since magnesium is more reactive, so magnesium will come into the solution as Mg2 plus aqueous ion. And zinc will gain the 2 electrons given by the magnesium and it will turn into zinc solid. Explain why the reaction between magnesium atoms and zinc ions is both oxidation and reduction. So magnesium atoms are oxidized because they lose electron. Alright, so magnesium is going from Mg to Mg2 plus. Whereas the zinc ions are reduced because they gain electron. So Zn2 plus ion is gaining 2 electrons to become neutral zinc atoms. The reaction between hydrogen and oxygen releases energy. A student drew a reaction profile for the reaction between hydrogen and oxygen. Figure 3 shows the student's reaction profile. We can see hydrogen reacting with oxygen. and producing water. Overall energy change is endothermic. Activation energy is shown here. The student made two errors when drawing the reaction profile. Describe the two errors. According to the student, what we see is that the overall energy change is endothermic. So the overall energy change is endothermic. However, reaction between hydrogen and oxygen is exothermic. All right. The second mistake the student made is activation energy is from the reactant portion up until the top, energy level that the reactant must reach before the reaction is started. All right. The minimum amount of energy needed. So it starts from the level of the reactant, the energy level of the reactant up until the top. All right. So that is also wrong. The reaction between hydrogen and oxygen in a hydrogen fuel cell is used to produce electricity. Hydrogen fuel cells and rechargeable cells are used to power some cars. Give to advantage of using hydrogen fuel cells instead of using rechargeable cells to power cars. So when using a hydrogen fuel cell, you see hydrogen, when it reacts with oxygen in the air, it produces water, which is not toxic chemical that needs to be disposed at the ends of the cell cycle. And then it takes less time to refuel the hydrogen, fuel cell car, traveling farther, all right, before refueling is possible, all right, and no loss of efficiency over time. We know that, in a lithium or rechargeable cell car, all right, the problem is that slowly the battery loses its capacity. Reactions occur at the positive electrode and at the negative electrode in a hydrogen fuel cell. Write a half equation for one of these reactions. So, to write a half equation, we can write either hydrogen turning into 2H plus ion and giving off 2 electron, or we can write oxygen accepting 4H plus ion and 4 electron and turning into water, or we can write oxygen reacting with 2 water molecule with 4 electron turning into 4 hydroxide. However, guys, I prefer these two equations because they're easy to remember and they are, you are more likely to remember them compared to this last one. The three states of matter can be represented by simple particle model. Figure 4 shows a sample model for hydrogen gas. Give two limitations of the simple particle model for hydrogen gas. Hydrogen is not shown as H2 molecules, all right? And the second limitation we would say is that the particles are shown as just spheres, okay? All right. Also, we can see that the particles are shown as solid. The particle does not show the weak forces between the particles, all right? And it does not show movement of the particles in any way. And this is only a two-dimensional image, all right? So these are the limitations, guys. So I'm going to give you only 2 points from here. You could use the other rest of the points as well. The hydrogen gas needed to power a car for 400 km would occupy a large volume. Suggest one way that this volume can be reduced. So the volume can be reduced under pressure or by cooling the hydrogen, and then it becomes a liquid, so it requires less volume. Or we can absorb the hydrogen in a solid. All right, we can absorb it in a solid, and once it gets absorbed in the solid, then it will have lower volume. The energy needed for a car powered by a hydrogen fuel cell to travel 100 km is 58 megajoules. The energy released when 1 mole of hydrogen gas reacts with oxygen is 290 kilojoule. The volume of 1 mole of a gas at room temperature and pressure is 24 dm3. Calculate the volume of hydrogen gas at room temperature and pressure needed for the car to travel 100 km. So 58 megajoules is equals to 58,000 kilojoules. All right. Since we require 290 kilojoule, okay, so we are going to moles, all right, moles equals to 58 moles of hydrogen equals to 58,000 kilojoules divided by 290 kilojoules. This gives us 200 moles of hydrogen. So the volume is equals to 200 times 24, 4,800. This question is about halogens. Table 5 shows the melting point and boiling point of some halogens. All right, fluorine, chlorine, and bromine, 3 information provided. What is the state of bromine at 0 degrees Celsius and at 100 degrees Celsius? So, at 0 degrees Celsius, bromine, since its melting point is below 0 degrees Celsius, is going to be a liquid. And at 100 degrees Celsius, since bromine has a boiling point of 59 degrees Celsius, it's going to be a gas. So this is going to be the correct answer. Explain the trend in boiling point of the halogen shown in table 5. So in terms of boiling point, if you notice, as we go down the group, the boiling point increases. Now, the explanation is the relative molecular mass also increases. Okay. And since the relative molecular mass is increasing, the intermolecular force between these molecules, all right, also increases. So more energy is needed to overcome the intermolecular force between these molecules. That's why the boiling point is higher. Why it is not correct to say the boiling point of a single bromine molecule is 59 degrees Celsius? Boiling point is actually a bulk property, all right? And it depends on intermolecular forces. So for a single bromine molecule, we cannot conclude, all right, about its volume. Iron reacts with each of the halogen in their gaseous form. Figure 5 shows the apparatus used. Halogen gas in iron is reacting with the halogen gas. Excess halogen gas is getting out of here. Give one reason why this experiment should be done in a fume cupboard. The main reason why we need to do it in a fume cupboard is this halogen gas, because it is highly toxic. Explain why the reactivity of the halogen decreases going down the group. Going down the group, the outer electron goes farther from the nucleus. So the nucleus has less attraction for outer electron. And since the nucleus has a less attraction for the outer electron, it becomes increasingly difficult for the halogen atom to gain an electron. All right. A teacher investigated the reaction of iron with chlorine using the apparatus in figure 5. The word equation for the reaction iron plus chlorine, iron chloride. The teacher weighed the glass tube and iron before the reaction, the glass tube and iron after the reaction. Okay. So glass tube and iron chloride, this is the mass. Glass tube and iron, this was the mass. And glass tube alone, this is the mass. Calculate the simplest number ratio of moles of iron atoms and moles of chlorine atoms. Determine the balance equation for the reaction. So, first of all, we need to find out the mass of iron. Guys, to find out the mass of iron, we are going to take the glass tube and iron, 56.04, and we're going to subtract it from the glass tube, which is 51.56. And when we do that, our value will be 0. Our value will be 4.48. Okay, guys. After we are done with that, now we need to know the mass of chlorine. All right. So mass of chlorine. In order to find out the mass of chlorine, we can take the glass tube and iron chloride's mass, which is 64.56, and then subtract, all right, 56.04, which is the mass of glass tube and the iron. So our answer is 8.52. Okay. Okay, now we are going to do our second step, which is we're going to find moles. First of all, we're going to find moles of iron. So when we are finding moles of iron, it's going to be 4.48 divided by 56, which is 0.08 mole. Then we are going to find moles of chlorine. When you're going to find moles of chlorine, it's going to be 8.52, which is then divided by, all right, the mole for chlorine, which is 35.5. All right, and we get 0.24. Then we are going to do iron is to chlorine ratio. When we are going to do iron is to chlorine ratio, we get, all right, 0.08 is to 0.24. The ratio is 1:3. All right. So, all right, moles of iron atoms, moles of chlorine atoms. When we take this into consideration, we have in terms of, moles of iron atoms, we have 1 iron atom and 3 chlorine atom. So the equation for the reaction will be iron reacting with chlorine to produce FeCl3. This one represents FeCl3. To balance this equation, we will now have to have 3 over here because chlorine is diatomic. So when 3 multiplied by 2 is going to be 6. So we're going to put a 2 over here. All right, which also makes 2 times 3. 2 times 3 equals to 6. All right, now we have 2 irons. To balance that, we are going to put a 2 in front of the iron. This question is about citric acid. Citric acid is a solid. A student investigated the temperature change during the reaction between citric acid and sodium hydrogen carbonate solution. This is the method used. Pour 25 cm of sodium hydrogen carbonate solution into a polystyrene cup. Measure the temperature of the sodium hydrogen carbonate solution. Add 0.2 gram of citric acid to the polystyrene cup. Stir the solution. Measure the temperature of the solution. Repeat steps 3 to 5 until a total of 2 grams of citric acid has been added. The student plotted the results on a graph. Okay, we can see the graph. Very nice. We can see in the graph there is an anomalous result. Okay, now figure 6 shows an anomalous point at 0.6 grams of citric acid was added. This was caused by the student making an error. The student correctly measured the mass of citric acid and also read the thermometer and also plotted the point. Suggest one reason for the anomalous point. Okay, in order for this particular, because this reaction is endothermic, in order for this particular reaction to occur, we need to stir the citric acid with this, sodium hydrogen carbonate. Now, if the student is unable to stir it properly, then obviously the reaction will not happen fast enough, and as a result, the temperature will not decrease. All right. So probably the student didn't stir the solution enough. Explain the shape of the graph in terms of energy transfer taking place. You should use data in figure 6 in your answer. So the temperature decreases. Guys, we can see the temperature decreases initially because the energy is taken in by the reaction from the solution. When 1.5 grams of citric acid is added to this particular solution, all the sodium hydrogen carbonate has been reacted. That means after that, any addition of citric acid, it's in excess. There is no more sodium hydrogen carbonate solution left. As a result, all right, the temperature increases as energy from the room, all right, from the surrounding is transferred into the solution, and the solution slowly warms up. A second student repeated the investigation using a metal container instead of the polystyrene cup. The container and the cup were the same size and shape. Sketch the line on figure 6 to show students' results until 1 gram of citric acid has been added. The starting temperature of the solution was the same. So the explanation for this particular answer will be, as the metal is a better conductor, more energy is absorbed from the surrounding and the solution warms up faster, which is why the solution does not decrease in temperature as much as that of the polystyrene cup. The student used a solution of citric acid to determine the concentration of solution of sodium hydroxide titration. The student made 250 cm cube of solution of citric acid of concentration 0.05 mol per dm cube. Calculate the mass of citric acid required. Relative atomic mass given here. So the amount of citric acid will be C6H8O7, 6 times 12 for the 6 carbon, and then 1 times 8 for the 8 hydrogen, and 16 times 7 for the 7 oxygens. So the total is 192. Now we're going to find out moles. In order to find out moles, we have a volume of 250 cm cube. The cm cube needs to be converted to dm cube, so we're going to divide by 1000 to convert it into dm cube. And then we're going to multiply with the concentration, which is 0.05. Once we multiply with the concentration, our answer comes 0.0125 moles. Finally, the mass. The mass will be, to find out the mass, we're going to multiply the number of moles, 0.0125, with the MR, which is 192. All right. And we're going to get 2.4 grams. This is the part of the method the student used for the titration. Measure 25 cm cube of sodium hydroxide solution into a conical flask using a pipette. Add a few drops of indicator to the flask. Fill a burette with citric acid solution. Describe how the student would complete the titration. So what we need to do is we need to add the citric acid to the flask. All right. And we need to keep adding it until there is a permanent color change. And we need to measure and record the volume of the citric acid that we have added. Additional point should be that the reaction should be performed on top of a white tile so that the color change is seen correctly. A conical flask, the flask should be shaken or swirled, all right, so that the reaction mixture gets enough amount of stirring so that it can mix, all right, mix properly, and repeat the process, all right, so that we can calculate an average. Give two reasons why a burette is used for the citric acid solution. The main reason why we are using a burette because we are adding a variable quantity, all right? And we can add the citric acid in small increments, a little drop by drop. We can measure the variable volumes as well, all right? It is more accurate in comparison to that of a measuring cylinder, or at least we have a better control of how much we want to add the citric acid. 13.3 cm cube of 0.05 mole per dm cube citric acid solution was needed to neutralize 25 cm cube of sodium hydroxide solution. Sodium hydroxide plus citric acid, sodium citrate, and water is produced. Calculate the concentration of sodium hydroxide solution in mole per dm cube. Guys, to do this particular calculation, what we're going to do is we're going to first of all find out the moles for citric acid. Once we get the moles for citric acid, we're going to find out the moles for sodium hydroxide. Once we get the moles for sodium hydroxide from, once we get the moles for citric acid, then we're going to use the reaction stoichiometry, all right? Because 1 mole of citric acid reacts with 3 moles of sodium hydroxide, then we will be able to find out the moles for sodium hydroxide. Once we get the moles for sodium hydroxide, we can then calculate the concentration by using the volume of sodium hydroxide, which is 25 cm mentioned over here. So guys, that's the end of the question paper. Thank you for joining this particular video. Guys, videos like this are going to be uploaded every day. If you have any suggestions for improvement, I know there is a lot of room for improvement. Please let me know in the comments, and share this particular information with your friends that videos like this are uploaded every day. All right, and you can massively benefit from this particular videos. Guys, thank you for watching. And guys, I'm located in Dubai, all right, near the metro. If you are nearby and you are looking forward for home tuitions, or if you want tuitions over here as well, guys, please let me know. All right, and I'll give you my email and you can contact. Thank you guys. Thank you for watching the video. See you in the next video. Bye bye.